Okay, so we just wrapped up the 289 out there.
Yeah.
Had it on the dyno. If you guys didn't see that build series, go check it out. This is kind of its bigger brother.
Yeah, big brother.
It's a 351 Windsor. This actually belongs to one of our neighbors, and this is actually a freshly built engine.
Yeah, it's been several years, but it doesn't have any time on it.
He actually took it somewhere else to have the work done. He had been fighting with getting it to run. I don't know the full details of what his issues were. He finally determined that he thought maybe he had a flat camshaft because it was a flat tappet cam, and he was worried about having not broken it in correctly. When he tore the cam out, turns out the cam wasn't. Cam looks fine. He also thought he saw some metal in the oil at some point. So what he's asked us to do here is basically take it apart.
Take it apart, clean it up, see what he's got.
Make sure it's good to go. Our hope is that maybe we can just kind of freshen it up, put a few new parts in it, and then see if we can get it broken in on the dyno for him so that he can move on with his
get it back
project.
in his truck and know it's going to run when he puts it in.
Yeah.
Let's
I guess pop the heads off to start. And the goal isn't necessarily to critique anybody's work, but we are going to go through it and make sure it's right to our standards at least.
Those are not very tight. Has he had the heads back off?
I have no idea if he has.
Huh.
Rusty. So our shop is about 15 miles from the nearest decent grocery store, which means running out for even just a few things turns into a serious time commitment. That's exactly why Thrive Market, the sponsor of today's video, has become our go-to for groceries. It's a membership-based online grocery store that delivers healthy, high-quality food and essentials right to your door. And everything's priced lower than what I'd pay normally locally, especially when you factor in gas and time saved. I bring my little girl to work with me most days, and she's about 15 months old, so snacks for her are a big priority, and they're honestly a key to keeping her happy at the shop. So this time we stocked up on some things like these Once Upon a Farm tractor wheels, freeze-dried strawberries, and Annie's Bunny Grams. They have all clean ingredients, and there's nothing weird on the labels that I can't pronounce. Plus, they show up right to our doorstep, so I don't have to walk through the store trying to find all these things. My little girl isn't the only one who needs snacks, because we like snacks around here too, so I stocked up on some Pirates Booty. I ate so many bags of this during college, it's not even funny. And back then I had no idea it was healthy, it was just what they had at the dining hall. We also picked up some Poppy soda. We're trying to cut down on our more traditional soda drinking. But they have household items too, like sunscreen that I picked up for an upcoming trip to Florida, and some treats for the dogs, because they're family too. I love that I can quickly throw snacks, pantry items, pet treats, even household stuff like the sunscreen all into one order and be done without having to wander the entire store, dealing with the crowds of people that I don't want to be around. To me, Thrive Market is all about eating well without wasting time or money. We get exactly what we need quickly and without paying those crazy health food store prices. And it's all organized by diet. So if you're shopping gluten-free, organic, low sugar, or vegan, it's super easy to filter and find what fits your family. If you want to give it a shot, click the link in my description box or go to thrivemarket.com/JimsAutomotive to receive 30% off your first order and a free gift when you join Thrive Market today. Thank you to Thrive Market for sponsoring today's video.
Yeah, he's definitely had the spec part.
Yeah. Oh, there's not
even a head gasket in it.
Okay.
Yeah, looks like the heads have been done. In fact, the heads look like they have brand new valve springs on them. They've been surfaced. You can still see plenty of the crosshatch in the cylinders there. They look nice from what I can see at that
so far.
point. Yeah. It's obvious it's been run. Yeah, that one's washed a little bit. Yeah, that one, there's actually some rust that started growing there. Yeah, in fact, look at this cylinder here. Let's run that piston all the way down. You can see in there where it has sat with moisture in it. I don't know, it's just kind of dirty. It kind of looks like some metallic in that. So I don't know what he's got.
So it's got ARP bolts on the rods.
Yes, those are ARP bolts, and it appears it's been balanced.
Yeah.
We were discussing that a little bit, whether or not we would need to balance this engine, but it looks like it has been already.
We're hoping here is maybe we can touch it up in the hone, polish the crank if it even needs it, and put it back together for him. And
Yeah. He was almost talking about just kind of tossing this engine aside. And I told him, I said, you know what, you got this much money invested in it here, why don't you freshen it up and see if you can get, at least salvage something out of this.
yeah.
You see anything in the screen?
I don't see anything in the screen, really. That's a little metallic.
Is it?
I think so.
It's new pump. Melling M83. Whoops. There it goes. Ooh, that's not looking good for brand new.
That has a lot of something embedded in it, too.
Yeah, this one is mostly it's kind of scratched. Bunch of specks of things in this one kind of embedded into it.
How's the crank look?
Well, I was going to say, I think the crank itself looks okay. So the skirt on the piston looks nice. 463P in 60, so it's already a 60 over motor. Rods have been resized and the ARP bolts. I mean, that part of it looks fine. Well, I would say the rings are quite worn already for as new as it is.
Can you do that so I don't
Yeah.
hit the crank?
I wonder if he did have some real bad fuel problems. Kind of washed the cylinders right away.
Skirt looks okay though.
Yeah, skirt looks brand new. This one's the same way. What are those black specks?
That is interesting.
Wow, look at this one, how worn it is. Of course, you made some marks in there with your
With my hammer.
hammer, but you can still see the how much wear there is in that bearing already. Crank looks pretty.
Fine.
Yeah. That it?
Yeah, just all of them are.
Huh. What size are they?
20.
Now this one has kind of the scratches, but not the specks. That one has a couple of specks in it. So again, piston looks real nice. Yes, he's had some of these apart. Didn't need that nut anyway, did we?
No. Well, I hope he's had that one apart because cap's on backwards.
Doesn't look the way I would want it to look.
All of the bearings pretty much look the same.
I'll bet he diluted his oil with fuel. With the way the bearings look, how worn the rings are already. That one, what size are these? 20s. 3rd month of 17. 8 years. I think there's definitely been a issue with the oil. Well, it looks to me like there hasn't been any lubrication or adequate lubrication between
The bearings.
the bearing and the crankshaft, and it's just, and there's some lines, little lines on here. Easier. There you go. There's quite a bit of wear on the rear, a little less on that one. Quite a bit on the front, not so much there. But look at the center bearing.
Nothing.
For almost nothing other than some little scratches where stuff has gone through it. I'm guessing the line bore on this motor is not quite as good as it could be. Oh, they did line hone it.
Yeah.
Or they at least touched it up. Is that what they did? Yeah, they didn't cut the caps. They just touched it up. So we do need to check that real close before we go back together. Look at the funny wear marks.
So is that a lack of a torque plate? The cam and lifters and everything were already out when it got to us,
Yeah.
but looking through all of them,
Really don't see anything. I mean, none of the grinding marks are still there anymore.
yeah.
We really don't know how much time, how much run time this engine has on it. So I don't know if that's excessive wear or not, but they are mated together.
Yeah.
They're definitely not, it would not have gone flat. Camshaft here, looking at it, the wear pattern that shows on here, you can obviously see that there is some taper ground in these lobes that would allow the lifter to rotate as they're supposed to. This is definitely not what its problem was. The rocker arms I'm not real crazy about. I think they should have been replaced. There's quite a little bit of wear down here in the fulcrum area, some more than others. Pretty good groove in there. Had I been doing this engine the first time around, I would have replaced those. But, I mean, that isn't what caused all of his problem here.
Yeah.
They were working fine. I just would have liked a little bit better rocker arm back on there.
At this point, we can't point any fingers at whoever
No,
did this
I
engine
think-
because
I think the machine work was done fine. I think it's more a problem that he had a hard time getting it started, and we need to ask him some more questions about just what was going on when you first started this engine.
yeah.
Something I see here, probably the worst thing I have seen on this motor, you know, if I'm going to pick at it, the worst thing I have seen so far is this right here. They used red silicone in there to seal that freeze plug when they put it in, and look at that stuff. It's just barely, what it pushed forward is just barely hanging there, just that much, and it's loose, and that could easily then pump right down the oil gully there, right into your valve lifters, and create you some problems. So in my opinion, silicone is not the correct sealer to use on an expansion plug. I just want to point that out to you people. Don't use silicone on a freeze plug like that. That's not the right place for that to be. Heads look like they have brand new springs on them. So they did put positive seals on the valves. That's exactly what we would have done. Wiggle test, the guides feel pretty good. It does have replacement guides in there. Look how rusty this port here is though. So I think the heads were done probably as well as they could be. Nothing much to see there.
Okay. So we'll go through, clean everything up, and pick up from there.
Yeah.
So I've got the block cleaned up here. We went ahead and baked it and blasted it, and we're gonna deck the block and I'm going to touch up the cylinders in the hone. But we've got a boo-boo on the back of the block and a boo-boo on the front of the block that we need to fix first. And we also need to torque the main caps on and see if we can tell anything obvious with the main bores. So on the back of the block, we have a broken bell housing bolt. And it appears that somebody before me has already made some attempts at extracting it. So I'm not sure what really is broken off there. I don't know if there might be an easy out there or if there's a drill bit there, but I'm gonna start with just trying to drill it out a little bit and see what we can see. I decided I'd rather weld a nut on here. So I think that little round spot there used to be in there was possibly a drill bit. And I think that I'm also looking at a broken easy out. I'm gonna try to weld it again. Probably. Yeah, there's definitely an easy out right there.
Oh yeah.
My burr will not even touch that. Really what would be nice is if I could just get that easy out to come loose. How do we do this? How long is that easy out? Here it went. The bottom of the easy out,
Whoops.
I think, is right there.
Yeah.
Okay, I think I'm past easy out. Might be a tomorrow problem. Okay, so I've been dicking with this for longer than I wanted to be. And at this point, I've kind of used an end mill to try and go in and thin out what's left of that bolt to where it's just the threads, just like this piece here. And then I'm going in with the tap and just trying to push those pieces back out. You gotta be pretty careful doing this because you don't want to break a tap and have even more mess. But you can see the weld trick hadn't been working, and at this point we're so deep down in the hole that the weld trick could result in actually welding the hole shut if you're not careful. So I think we're pretty close to getting it taken care of here. Probably shouldn't say that, but I think I've got it all. I went in with a drill bit one more time and this little piece came out, which appears to be the bottom of the bolt.
What's all that?
That's what's left of the bolt.
Got your buns.
So the boo-boo on the front of the block, someone somewhere along the way installed too long of a bolt here. They bottomed out this bolt, kept tightening it down, and dang near broke that ear off. That almost condemned this block right there. I'm sure there's other ways you could have fixed it, and I'm curious to see what people say how they would have fixed it. But here's my plan. This hole is actually a blind hole, but there's still material there between the bottom of that hole and the water jacket. So what we're gonna do is we're gonna drill all the way through into the water jacket, And then I'm going to counterbore these upper threads down to past where that crack is. And I'm going to tap new threads in the new good material, you know, into the water jacket there. And then when we install this, we'll install it with a stud with a bunch of sealer on it to seal that bolt going into the water jacket. And hopefully what that'll do is pull this back down tight, because right now it's actually, you can't tell, but that piece is actually raised just a little bit off the surface here. And by doing that, it'll pull it down tight and should hopefully seal and give this block a chance at a little bit more life. I'll just go through and do it by hand. Should be good. So now, hopefully, we have nice threads down here in the block. We'll install a stud with sealer. You can see you wouldn't want to screw this in so far that you would go through into the block or into the cylinder wall, but hopefully now we'll have some good threads to be able to pull that down tight and get it to seal. It looked like the previous shop had, at the very least, ran the line hone mandrel through the mains. We don't really have a good way of checking if they're aligned, but we can at least go in and double check the size. So right now this gauge is set up so that 0 is the minimum side of the specification. I don't have it pulled up here right now, but they give you an 8/10 thousandths of an inch tolerance on the diameter of the main bores here. So 0 is the small side of that spec, and 8 little marks to the left of 0 on the plus side there would be the big side of spec. And what we get when we're checking here, we're in the realm of probably almost 1/1000ths larger than we're supposed to be. And they're pretty consistent in that range from what I've checked so far. So you guys are gonna have to tell me. I've never attempted this before, but we had the idea. We said, let's give it a shot and see what we can do. What I'm essentially doing is taking the main caps, and this is a pretty flat surface here, and I've got some sandpaper there, and I am just touching these main caps up roughly about 1/1000th of an inch to see if we can tighten up that dimension to get it within our tolerance for the diameter of that bore. So I've already done number 2 here, and I'll show you what that process looks like. But now you can see we're about 4 to 5/10ths larger than the minimum side of that diameter tolerance. So I've brought it back to within tolerance with just a small amount of sanding here. Okay, so number 1 main cap here, we need to remove about 1/1000th to get us kind of right within tolerance range. So I've got this set up here with our deck bridge and rocking to find the high spot there. It's right on 0. Honing oil seems to be working good on here, and just trying to apply pretty even pressure on here. Maybe flip it back and forth. And we'll go check. So you can see we've got kind of a sanded finish there now, and I'll just double check with our deck bridge again. Okay, so I went ahead and torqued that cap back on. So right now, I'm like in the very middle of spec, and we're just gonna go down the line. And again, remember we were about 1/7, 1/8 to start with, which is about a full 1/1000th outside of spec. So I'll go through and finish these other 2 up. 3 up. Now that we've got the mains sorted out, I've got the block up here on our surfacing mill. Probably would have been fine to just leave it alone, but it's not going to take too much work to go ahead and surface both sides of the deck, make sure everything is, make sure we have a good surface for our head gaskets to seal. It should clean up pretty dang quick. I did put a little bit of color on the surface so that you guys can hopefully see. Call that 0. I'm gonna take 1 thou just for fun to see how close our setup is to the last guy's. One thou dang near cleaned it. I said dang near, not it did. Completely cleaned up, except this front corner. So I'll do another pass here and catch up with you then. This side touched 9 thousandths higher than the other side. Yeah. To do the right side first? I don't know. So make it match? Make it match. Okay. Yeah, this side touched at 8 thousandths on the Z-axis here, whereas that side touched, well, I zeroed when that side first touched, and then we cut to -3. This one touched when I was reading 8 thousandths, so I'm doing an initial 5 thousandths cut here. I guess I'll do a 5 and then a 3 and then a 2 thou finish cut. And at that point, the deck heights will be the same from side to side. So I've got the block up here in the cylinder hone. I honestly don't know how much material we're gonna have to remove. The goal being to get, number one, the right surface finish back in these cylinders, because if we did have the oil get diluted with the fuel, it would make sense that our cylinders had more wear than we would have expected in 3 hours of runtime. So I've got the rough diamonds in here. Those are typically what we would take our last, 4 thousandths maybe after boring the cylinders here in the cylinder hone before moving to our finished stones that we plateau the cylinders with. Problem here is we're trying to remove as little material as possible because we're trying to avoid having excessive clearance on those factory style replacement pistons that the customer has for this engine. I have the torque plate bolted on here, and I've put some layout fluid on all of the cylinders here, and my plan here is to just go in and try to run the hone through and just touch each one of those cylinders, and then we'll take a look and see how out of round or how worn they might be. Okay, I'm thinking maybe 5 strokes here to start. Got a little bit of distortion there for sure. Let's do 5 strokes in all of them, and then we'll get the light in here, show you what I'm looking at. So you can see pretty significant spot right there where the hone is not touched at all. Towards the bottom, it looks like it's pretty well cleaned up. So this may be some distortion from the torque plate. Same thing on this cylinder. Again, there's a little bit in the bottom as well, but mostly right there at the top. This cylinder, I think we're seeing a little bit of that rust as well. Yeah, if you look there, you can see what appears to be kind of rust in the cylinder where maybe there was some moisture when it sat. And same kind of thing all over. Checking with the bore gauge, straight across there, we're about 3/10 larger than nominal bore size, but we're 2 thou there where it's worn, which is already starting to push the realm of excessive. So I've got them all. Right now we're roughly 1/1000th above nominal bore size on all four. So in other words, 1/1000th above minimum clearance for the pistons. And you can see we've still got, you know, there's a spot there. It pretty much cleaned up on this side, but we've still got one spot right there that is not cleaned up. And it's kind of the same spot across all of these cylinders. This one, it's pretty well cleaned up, but it's just a little bit of a shadow there. Not quite as shiny. This cylinder here, the second one, you can really see that corrosion showing up. So it's not our favorite thing to see, but kind of what you're going to see without boring a block. We're going to try another 1/2 thou over, and probably we'll call it quits there, regardless of how perfect it is. So after doing that, this is the only cylinder that we have a low spot like that at this point. The rest all look pretty good, with the exception of the little bit of rust pitting that we're seeing here. We're thinking we're just going to make this one cylinder about a 1/1000th bigger and see how it looks at that point, and probably call it good. We'll have that one front cylinder be a little bit bigger than the rest. I think that looks pretty good. It's not perfect, but it's pretty good. So at this point, I'll switch over to our finished stones and we'll put a plateau on this, double check it with the profilometer, and roll over and make the other side the same. I'm pretty happy with how this came out. Obviously, again, we're going to be on the looser side with the pistons. It's definitely more clearance than we would typically put on this if we were doing this as a brand new build. But you got to work with what you got here. Our surface finish came out pretty well in that same ballpark across all four. And we'll just show you here. There's maybe a couple tenths taper there, but we're kind of right in that 1.5 thousandths above nominal bore size. And on this cylinder, we're in the 2 thousandths above range. So let's take the torque plate off, pop over to the other side, and do the same thing. All looks good except for this one with just a little bit of rust again. 1.5. Yep. 1, 2, 3, 4, 5. 2, 3, 4, 5. 4, 5. 3, 4, 5. 13 on the peaks, 52 on the valley, 38 on the RK. That's an alright spot. Looks good.
Well, got the crankshaft cleaned up. I need to run a brush through the oil holes here yet, but it looks real nice, and when I measured it, it checks out on the tighter side of spec. So anyway, I'm feeling real good about this. Whoever did this crank did a real nice job on it. I don't see any issues at all with it, and there are some little spots. I don't know if you can see some of that staining. So this thing must have had some moisture in it when it sat, because it did stain it just a little bit, but it's fine. So let's go ahead and start up the polisher here and see if we can make it shine. Well, I think we'd be fine right there, but I kind of like the more satiny finish that those Scotch-Brite belts leave, so let's hit it with one of those now. So,
Looks good.
All right, so can we be done with it? Blow it off, bag it up?
Yep.
Okay. I have a head here from, let's see, it's a D5AECA casting from about a 1975 351 Windsor that I wanted to try to repair. But I have got one valve here that is just got the guide terribly worn out, and you can see it burned the valve away real bad, but they ran it so long, the valve seat is just totally worn away on one side, especially where that valve guide was worn so bad. And not only that one, but we've got another one over here. This one on this side is not quite so bad. I can easily salvage that, but I am not sure I'm going to be able to salvage this one over here. So I'm going to go ahead and I'm going to put one valve guide in this head, take the time to do that, and then we'll come back and see if I can put a large enough seat in to fill in that gap without cutting into the water jacket and having the head just totally be junk. There we go. And that obviously will not be my finished size, but it'll be finished out well enough that I can check to see if we can get a valve seat to stay in this head. Okay, here we go with our cut. Okay, I believe that's the bottom. Yeah, I cleaned up most of the pocket. There's a little shadow right up here at the top edge, but I'm not going to worry too much about that. Big pocket I cut for that seat. There's a little bit on the underside here that's going to be open, but there's plenty around there to hold the bottom side of that seat. There's a little shadow up on this edge that didn't quite clean, but there's plenty just below that to seal the seat up in there. So I think we're good shape. We'll see if we can get that driven in. Yes, we can. I like to blow underneath a little bit just in case there's any debris in there. There we are. It's almost there. I believe that's it. There's my new valve seat. Cleaned up the excessive wear from the old valve guide being out. You can see my new guide down in there. And by the time we cut our angles on that, be just as good as new. And we'll also put just standard size seats in the other exhaust holes. So this one we'll have one that's quite a bit larger, but I think it'll do the job for us. On these forward heads with the thermactor emissions, where there's a passage through the head here and then the little openings into the exhaust ports, one of the things we always do is make sure we remove these plugs on the end of that passageway and run a drill bit up through that. You would be amazed at the amount of carbon that is often stuck inside the end of these heads. So I'll run that through to make sure it's open, and then probably go back over in the glass bead machine again and blast through there to get that completely clean. Now on this head here, you know, these heads usually have that big old bump in the exhaust here where that air is injected into the exhaust port. It's not going to be used on this engine. There's no reason to have it there. All it does is restrict the exhaust. So I did give these back to our customer, and I handed him a couple of die grinders with some little burrs on there and little grinding wheels. And I got to thank him for taking his time to go up in there. And he actually did a pretty nice job. Ground that big old hump out of that casting. My gosh, when those are still in there, you can't even get your finger through the port. It is so restricted. But he opened them up for us, so I hope these will breathe a little bit better. And I want to thank him for that, because I certainly didn't want to spend the amount of time it takes to grind that out. And I thought it was a good experience for him to do that. With one of the heads mounted here on the guide machine, what I want to do is go through and pull out these press-in rocker arm studs. Since we are putting a mild camshaft in this, and I anticipate this young man to probably rev this thing maybe a little bit harder than it should be, we don't want any chance of these studs pulling out. So I need to go through, pull all these studs out, tap, drill and tap, so we can put screw-in studs in, and then we'll also drill out all of the valve guides and replace them. Hands over your ears. And there we have. Well, as you can see there, I've got one stud that gave me trouble. It probably had quite a bit of rust on the back side, because these do go through right into the water jacket. You can see here, I can just drop that screwdriver right down in to the water jacket. So what I'm going to do with that, I'll cut it off and we'll drill it paper thin and then drive it down into the water jacket, and then we can retrieve it out of there. So here goes. There it goes. You can see it moving down. Okay, there it just dropped into the water jacket. I should be able to retrieve that when we take the head off here and flip it over for some of the other procedures. So one of the first steps in getting ready to install a screw-in stud, and this is not the stud we're going to use. This is actually for a small block Chevrolet. I'm waiting for our studs to come in. Should be here in a couple days. But anyway, you have to cut this tower down the thickness of the nut portion of your screw-in stud, and then counterbore it just a little bit to allow for the lack of threads all the way to the top here on the nut. There's a little radius in there that you have to allow for. And then we'll tap the actual threads, 7/16, 14 thread I believe it is, on this. So first thing I'm going to start with is a spot face tool here, and we need to cut down about 250 thousandths from the top of every one of those towers. Okay, there's 90 thousandths. Leaves me a nice chamfer in the top there to allow for that area of that stud where their threads are not complete. They actually have to be drilled to 25/64 of an inch. Slightly larger than the 3/8 that those are right now. Come down, kind of touch off, find center. Actually, what works well sometimes is go backwards with it and pop the air, and then go forward. Again, I'm going to start it backwards. Just kind of use that to center up. Find the center of our hole there. Switch it to forward. A little bit of oil. I never tighten the chuck with a wrench when I have something like a tap in there, because even though it's hard on the chuck for that to slip in the jaws, I would rather it slip in the jaws than to have it bust the tap off. Something has to give, and hopefully it's the tap in the chuck rather than the tap breaking in the head. Hopefully when it hits the bottom it'll just slip and I can back it out of there. There we are. So at this point we should be ready to drill for the new valve guides. You've probably seen me do this many times before, but I have sprayed just a little lube inside the bore there. Have my new guides here. Okay, we need to shorten up the valve guides because the guides we put in are universal length, have to be cut to the correct length. Now I think we better put a valve in there with a retainer. Right there I've got 800 and almost 75 thousandths. So by the time we add even a couple hundred thousandths for the thickness of a valve seal on there, that would still give us 675 thousandths to the underside of the rotator, or underside of the retainer. I think that's more than enough clearance even for a fairly high lift cam. And we will finish the ID of the valve guides. I'm looking for just slightly over 1/1000th clearance, or maybe I need to back up on that. My intake valve will have a little over 1/1000th clearance. The exhaust will have closer to 2 because there is more clearance built into the stem of the exhaust valve, allowing you to make all the guides the same size, but in reality the exhaust will be 1/1000th looser. So I've got a little bit more to go here yet. I'm running about 1.5 clearance. Initially started out looking for a minimum of 1/1000th, but at 1/1000th my pilot did not fit the way I like it to fit. So I went back through and gave it just a little bit more to where it reads on the gauge here about 1.5. So I'll have 1.5 clearance on the intake valve, and that'll put about 2.5 on the exhaust valve, because the exhaust valve stem is ground 1/1000 smaller than the intake. We're ready to roll it back over here and put in the valve seats. They all fit nice and flush to the top here. So all that's left now is to put the finishing angles on there, and the valve work will be done. And remember, we're going to larger valves than this had before. The old valve here is about 1.78 inch, and our replacement is 1.8, maybe close to 40, 1.8, 40 inch. So not a lot bigger, but we're hoping that we can get a little more flow through these heads. So with that, I used my pointer here, and I took a measurement off of the valve, figured out where I want the outside of the seat to contact the valve, and I transferred that onto my cutter here. So we'll put that in the machine, lock it down, turn on some air, and let's see if we can open up the first valve seat to match our new valves. Not too bad. This being a performance application, I could probably go out just a little bit more, but otherwise this would be just about a perfect spot for the valve to contact the seat. 2.180 is roughly where the original valves are. So now when I check on my new valve I'm putting in, my oversized valve, 2.170, I'm probably about 10 thousandths from being the depth this valve was originally. The specifications I have over here say the deepest I want to be is 2.187. So roughly I can go about 10 thousandths deeper on this, and I should be just where we need to be. And that should about be my 10 thousandths. We'll make all the others match. Now that I've finished cutting all the rest of these seats so they are all exactly the same depth, I'm going to come back with this cutter here. I guess it could be maybe referred to as a bowl hog or whatever, but I'm going to go back in like I have on this one already and open that up right behind the seat in the port there. Take all the rough edges off there. Now we need to cut the exhaust seats. So once again, I have used my little pointer here to determine where I want the valve seat to contact the, or the outside of the valve seat to contact the valve. And then I can transfer that measurement here to the cutter. That'd be where the 30 meets the 45-degree angle. So I'll feather into that just a little bit. Change the speed. When you get to the point that you're cutting the full width of the cutter, it's really hard to keep the chatter down at times. Yeah, I like that. But we've got just a little bit to go before it would be on the edge of the valve. About as far out as we can be. That'll help these to flow a little bit better. Yeah, we can easily go in there 30 thousandths before we're where we need to be. Okay, there was another 30. I am just about exactly where I need to be. My seat was a little bit proud. I'm going to have to dress the top off there. I think if I take this down and make all the others match right now at this point, it'll make it easier to finish the seat itself. So let me set up a cutter to do that. Okay, I've put a rounded blade on my tool here. I'm hoping that will blend the top edge of that valve seat into the chamber and also into the top angle of the valve seat. So let's go in with this, see what happens. Okay, they're just touched off. Okay, again, I'm going to set my 0. I may change to another tool here and we'll open up the inside of the valve seat. I'm actually going to finish out the valve seats themselves first. And I think we can come down on the inside of these exhaust ports. I tried one here, it worked pretty well. And just blend it just a little bit. I'm not doing a lot here, not opening it up long ways, but mostly it's blending my new valve seat into the existing port. Okay, let me go down the line here and give you a little closer view of the finished valve seats. Remember, this one here is the one that had to put the big oversized seat in, and it even cleaned up. There's a little line underneath here where it was beat out bad. The seat didn't quite fill in, but that is purely cosmetic. It'll never ever cause any problem. I think they turned out very nice. I'm very happy with the valves, the way they sit in the chamber. You can see from the side here, they're all just a little bit proud. Look just like a brand new set of heads, which is what they are at this point. So I've got the head set up here, getting ready to surface it. I did set up a dial indicator here so I could indicate in and make sure that it was square to the machine. There, I can hear it just touching. And let's try 2,000, see what that looks like. I don't think the head is very far off from what I could see. You know what? This head cleaned up even better than I thought it might. I knew it wasn't off very much, but I always like to make the head gasket surface as perfect as we can. But there you see it. 2/1000ths on the DRO is all it took to clean that head. But we'll go ahead and give it another 1/1000ths finish cut just to get a little smoother surface. Actually, there's nothing wrong with the surface the way it is right now, but we can make it just a little bit better.
You know, I told you I wanted these done about 3 weeks ago. So where are you at?
Just finished that one. That's the finished cut.
That looks really nice, actually. Well, you told me to put the mic on and come over here. So.
Well, I figured you wanted to look at what I was doing and probably harass me about it.
Those look really nice.
Does it look okay?
Looks good.
So, yeah, we did the normal 3 angles plus an additional from the top and an additional from the bottom. And not trying to get fancy with them, but just to get everything blended in. So I hope they flow nice, and hopefully the larger valves were an improvement on these heads. And they aren't a performance valve or anything, it's just the larger valves like the early 351 Windsors had when they first came out in the early 70s.
But the smaller chamber is going to help us.
Smaller chamber is going to help us. So I've got my heads all cleaned. They've been run back through the spray wash and rinsed and blown off. I don't know if you guys are aware of this or not, but depending upon what kind of engine we're building, we often use different types of lubricants. This one being a performance engine, I did get out the spicy lube. I think that'll give it a little more boost in power here. And I think Caleb wants all he can get. So let me set the camera up here and I'll start slipping this thing together. We've heard numerous comments on other videos of us doing heads, always wanting to know about checking spring tension and height and everything like that. And we've just kind of glossed over that before. But on this engine, we really are paying particular attention to that, seeing as how I put all new valves and seats and everything in it. Our camshaft, well, let's say something else here. We also did screw-in studs on this. That last 289 we did, remember Nicholas, we had all the comments about why didn't you pin those studs or why didn't you put screw-in studs? Well, guess what? That 289 on a good day has 60 pounds seat pressure and maybe 175 open. From the research I could find, you really don't need screw-in studs until you're up there in the range of 280 pounds is where studs start pulling, or real high RPM, which that engine was going to see neither of those. But this engine will. So even though we're not going to have springs that high of tension, we did do the screw-in studs on this. So now I'm trying to figure out how to get my spring height set correctly. So I had to go through every single valve here with this little micrometer and put that on the valve, crank it up, and then you can measure on here exactly what your spring height is. So I've gone through every one of these and recorded that. I range from about 1.850 to maybe 1.865. A lot of times there's some variation in the spring pockets on the heads. This one was very close. I'm surprised it was as close as it is. So now I got to figure out my springs. Springs we got to go with our cam are 128 pounds at 1.75 inch. And I don't think we want that much pressure on them. I'd sooner have them a little light than too heavy and have problems with our camshaft.
Because we're going back flat tap at cam.
We're going back flat tap at cam, so we don't want to overdo. I mean, we have to have enough, but we don't want to overdo it. So, again, in doing my research, I came up that I think if we have 110 pounds seat pressure, we'll be fine, and maybe around 275 open. Based upon the spring rate, 350 pounds per inch, when you do your math on this, if I install these springs at about 1.8 inch instead of 1.75, we'll have about 110 pound seat pressure. And again, doing the math, when the valve is open with our roughly 460 lift cam, that's going to put us at 270 pounds open. So I think we're in a good spot with that. What do you think?
Sounds good to me.
Okay.
So how are you going to achieve?
Well,
because you said you're around 1.850.
Yeah, 1.850. But if I get valve keepers that are 50 thousandths plus installed height, I think I can just about hit my numbers.
Okay.
So I need to get those out, check a couple of these with them, and we'll be ready to put the seals on, put the springs on, and be done. And I believe we have our heads complete. Put new stainless steel. These are not just steel, they are stainless steel freeze plugs in the ends of the heads. I screwed the plugs back in the Thermactor emissions, so they do have a available bolt hole there to use. I can lay a straight edge across the top of my valve stems, and they are very close to being even all the way across. New springs, keepers, seals, retainers, all new valves. The only thing used on these heads is the casting itself, so they should perform very well. You can see we've drilled for the screw-in studs. We'll put those on when we have the heads on the engine. Only thing left for me to do is go back over here to Surdy, and I want to do one last vacuum test, make sure they're fine. Since these heads have that thermactor emission with the passage drilled through here into each exhaust port, I can't do a vacuum test over individual exhaust ports. So I'm going to have to do it over the combustion chamber. I'll be checking 2 valves at once here. But I'll just put my finger over the spark plug hole, put my vacuum pad on there, and you can see we're holding virtually perfect vacuum there. On every cylinder. Pulls way up there. If I actually shut the vacuum pump off, it just holds. It stays right there. Before we finish up here, I told Nicholas that I would like to check this engine and see what the true compression was. Kind of up to this point, I did check these heads before we started compared to the heads that the customer brought in and determined that these were smaller combustion chamber than what he had. Does have very dished pistons on that engine. By the book, it says it's supposed to be about 8-to-1 compression. I was hoping these heads would bring it up to maybe around 9-to-1. Still not ideal, but you have to sometimes work with what you got. And I'm going to show you a way here to check the volume of the combustion chamber on these heads, the poor man method. What I'm going to do here is start out with a little bit of our assembly lube, and I'm going to just put a light coating all around the outside of this combustion chamber. And I don't know if any of you people watch one of the other channels or not that has the little short videos, but I see videos on there all the time from a place called Moffett Glass. They are one of our local glass shops that do extensive videos on work they're doing in their shop, and encourage everyone to use your local glass shop. Well, that's what we did. This is a piece of plate glass I got from them at one point in time. It's nothing special, 1/4 inch thick. It's been sanded off on the edges so it's not sharp. And then I came back and taped this off and used our glass beater to blast a hole through the center of that. So if I lay that on here now, right over top where I put that lubrication on there, that will seal that glass to the combustion chamber. And then you can go to your local vet supply and get some syringes. And probably just use water or solvent. I'm using the coolant out of our crankshaft grinder just because it's a relatively benign liquid to use and will not rust the head here or the valves if I don't get this completely dried off. But I can fill that up with our liquid. Okay, right there, I'm at the 60 cc mark. So I'll go ahead and start filling the combustion chamber with that. I did screw a spark plug in, put a little grease around it so it wouldn't seep out of there. And you can see as the chamber fills up, this side over here is slightly higher, so all the bubbles should come to that side and bleed out. Yeah, you can see it filling in here. Just kind of carefully, slowly put that in so you don't splash it up out of there. And I can't believe this, but that is just about completely full. 60 cc's. I do have a smaller syringe here, 20 cc. Let's put just a little bit more in it. Get the bubbles out of there. I've watched the doctors on TV do this, so I'm sure I'm an expert now. I'm going to put 5 in there because it's not going to take very much here. Yeah, virtually nothing. So that is about a 60 cc head, which is pretty much exactly what the book said it should be. That's very, very close. So we'll go ahead and do this process on the top of the cylinder also to figure out how much volume there is on top of the piston and in the dish that is in the top of the piston. And then we can figure out the actual compression ratio of what this engine is going to be. So when you're done with this, all you got to do is go back in that hole, suck it back out of there, take my plate off, and I'll wipe this off and blow it off, blow it dry, and it'll be ready to go on the engine. So very simple, easy, inexpensive way to check the combustion chamber volume of your heads.
I ran it through the spray cabinet one more time, got it all cleaned up. I'm not sure what it is, but there's a little bit of staining on the deck after washing it. I'm not sure what the source of that was, but we're gonna go ahead and get cam bearings and freeze plugs installed so we can get this out into the other shop on the build stand and start putting this engine together. Went ahead and put our old cam in just to test fit, and turns real nice. A little bit of Loctite. So we had Delta Camshaft do us up another cam, just like they did on that 289. We'll go over the specs on this a little bit later in the video. I think I'm gonna get the cam installed, and then I'll go through and really lube up the lobes really well. Cam fits, spins real nice. We'll go through and do all of them just like that. Make sure they're good and coated.
Anyway, you might want one of them.
A little bit of lube. That all looks pretty nice. Here it goes. Yeah. And on the plane, but it's somebody else's baby, and it's super annoying. Set down there, and just kind of laid back and was. Yep. So I've got our degree wheel lined up so that we found true top dead center on #1 cylinder. Now I've got a lifter on the intake valve, and we're just gonna go through and record a couple of points here. I'm gonna spin this around until we're at 50 thousandths lift. Okay, right there is 50 thousandths lobe lift. And I'm gonna say we're about 0. 100 thousandths, 200 thousandths. So we're just before 30, and we've got 55, 56, 57, 58 and a half. Then we're gonna go past max lift. And there we are, 155, 6, 7, 8, 159, 200, 100, and we'll stop at 50 again to get our closing point. $30. So we're gonna install the timing cover. Everything looks good there. So I've got a thin layer on the back side. We've got one dowel here, alignment dowel. There could have been one on this side also, but we don't have it. In the last video, my dad showed using the damper to kind of help center the seal surface on the timing cover. And somebody commented that we should have printed a little alignment hub on our 3D printer. So that's actually what I did today to kind of maybe assist us a little bit in lining this up. Timing pointer. Click. 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 Next time I print one of these, I'll make it longer, I think. Just like that. Water pump going on. We're going to use this stud. Well, it's not a stud yet, but we'll cut it off and make it into a stud once we know how deep it needs to be. But I'm going to lather this up with green Loctite in the hopes that we can seal this from ever leaking. just like that. Nearly made a rookie move and forgot the oil pump drive shaft. Okay, we'll get that all torqued back down and put the pan back on.
Just like what I did in there on the heads, I want to put this piece of glass over the top, and we'll use syringes to measure how many cc's is in the combustion area of the piston.
Roughly.
So, roughly, yeah, it's roughly. And that's why I said this is poor man's method. It's a cheap way of doing it. I mean, the most expensive thing, well, you'd have to probably buy some syringes unless you have a friend with some.
Jesus.
But we don't want, I'm going to use crankshaft grinder coolant for our liquid in here. And because it's a coolant, it won't rust anything, but we still don't want to get a bunch of the coolant down around the rings. So why don't you take your assembly lube, wherever it is, and just run a bead
Just around the top.
around the top there. And then if you bring the piston to the top, it'll kind of seal it off,
Yeah.
so it doesn't get around the rings or caulking stuff in your house.
And part of what prompted us to do this is once we got the short block assembled here, we realized that, what do all the pistons on that side read?
From 37 to 40.
So on that side, we're from 37 to 40 in the hole. And on this side, we're from 42 to 49 in the hole. And it's not a deck height thing. We know the deck height is good. Plus, if it was a deck height being off one way or another, it'd be even on both sides. But this is more like whoever resized the rods cut a whole bunch off the rods, or they mixed and matched rods. Who knows if this was a matched set
To begin with.
because this has been rebuilt at least twice.
Yeah, twice
based on the
before we got a hold
crankshaft.
of it.
And you know, if the crankshaft had a rod out at some point,
And maybe the stroke is not correct on the crankshaft, but that doesn't necessarily make sense with the way it is either. Okay, so Nicholas is bringing that up to the top and watching the dial indicator. Let's wipe some of that excess oil off the top. Just lay me just a real small little bead. Okay, so that should be sealed. Okay, that should be very close to 60 cc's.
Okay.
So let's see what's in here. Okay, I would say we're pretty well full at that point, don't you think? So we went from 60 to about 37-ish. So what is that, 23? Okay, so now we need to go sit down with one of those formulas on process, and we'll figure out what the actual compression ratio is.
Okay, well, I was just hoping I could get it. Huh. Looks like it. So I want to make sure our timing pointer is pointing at true top dead center, number one cylinder there on our damper. So what I'm going to do here, the dial indicator there on number 1 cylinder. And I'm gonna turn the crank. You can see top dead center is somewhere over here. I'm gonna stop at 50, if I can. And now I'm gonna read where we're at on our pointer. And we are reading 6 degrees before top dead center. So now I'm gonna go past top dead center and right back down to 50, right about there. And I'm gonna say we're reading pretty much 6 degrees after top dead center here. It's hard to see, but it is in the right spot, it looks like. Head gasket is marked front. Same thing on this side. It looks like it's upside down, but it's marked front, so we put that towards the front. So for our lifters, we're using the ones from Delta that have that little flat ground down the side. Theoretically, maybe lets a little bit more oil go down and spray right on the cam. First, I'm gonna lube up all the lifter bores. I'm gonna put in our screw-in rockers. We're using rail type rockers, so we're not actually installing guide plates on these. The studs are drilled through into the water jacket, so we do have to seal these. So I'm gonna use this sealer that is actually hydraulic, high pressure thread sealant. Going to use it generously. So I've got the engine turned right now so that it's on top dead center on compression stroke, number 1 cylinder. We know that the lifters are both on the base circle of the camshaft, and that's where you want to do your rocker adjustment at. Okay, right there is 0 lash. I'm gonna go a half a turn past. Do the same thing on the exhaust side since we're also on the base circle on the exhaust side. I think I just started to feel right there is 0 lash. So again, I'm gonna go half a turn. From there, we just rotate the engine a quarter of a turn and go through the firing order and make all of our adjustments the same. Okay, and I'm gonna put a pretty fat bead across the ends here. That should work. Okay. Okay, so we're to the point of putting oil in. We're doing the driven BR30 brake-in oil again. It's good for the rings, but it's even better for the flat tap cam.
Yeah. I'm more concerned about the cam than anything else.
Yeah, but it's good to use a brake-in oil even on a roller cam motor too.
Yes.
But especially on a flat tappet. There, we got pressure. Okay, so we're adding one last quart of brake-in oil to the 351 here. We've got everything up on the dyno, new carb. We've got their Pertronics flame, what do they call it? Flamethrower.
Yeah. Customer
supplied.
Yeah.
So we're getting ready to start this up and do our break-in. Hopefully it fires up right away and we can get it up to about 2,000 RPM. He's gonna work on setting the timing. I'm just gonna kind of watch, I guess, temperature and stuff like that, oil pressure.
Yeah, watch your temperature and oil pressure. After we get it kind of halfway set here, I would suggest putting a little bit of load on it.
Yeah, throughout the break-in, I'll probably
kind of run it up and down. And
yeah, like we did on the 289 a few weeks ago, we just up and down with the load. Belt here for the water pump is not really the right length belt, so we kind of have a little idler tensioner here. I don't know if that's gonna work or not.
We'll find out.
You ready?
Go ahead. Try that. Again. Come on.
What's it doing?
Shut it off a second.
Okay, ignition, fuel pump. Ready?
Yeah. Turn it off. Let's kind of double check where our timing is at, or where I think it's at. Okay. Shut it off. Again.
Ready?
Yep. No.
At this point in the process, we were really starting to question the distributor. We wanted to go back to the basics with a points-style distributor, but the best we could come up with on a Friday afternoon on short notice was a used HEI style that we found on Facebook Marketplace.
There we go.
That can't be right.
Might be. Now what is it? Yeah, can. No, it's not. Let yours off. Let's shut it off.
Shut it off?
Yeah.
Okay, so we go to 15 minutes here.
Yeah.
And
I was gonna say, try loading it just a little bit again, see what it does. Let it run like that if it will. How many RPM is that?
that's 900. This is reading 26. That can't be right, can it?
It might be.
Defeated enough at this point, just thinking of other things. Could I have screwed up the timing set?
Right.
Because I don't know if I even showed this in the video, but we contemplated putting a double roller adjustable timing set on. But when I installed it, it was like, it would have been 8 degrees advance or retard, and it put us farther off than we wanted to be, because we don't have enough keyways on that particular timing set that we had in stock. So we said, okay, let's go back to the stock timing set. So I had degreed the cam with the stock timing set. I degreed it with the aftermarket timing set. Then I put the stock timing set back on, and I just lined up the dots, I thought. My camera angle is not straight on, so we can't tell if they actually were lined up, but we're just questioning, could we be one tooth off at this point?
Yeah.
Could the cam be one tooth?
Either advanced or retarded.
Right. So what we're gonna do, we tried putting an indicator on here, but the lifter bleeds off, so you can't really tell how much lift you actually have. So we're gonna take this rocker off, the #1 intake. That is the intake, yeah.
Yeah.
I'm like, are we on the...
Are we even on the right valve? Are we on the right engine?
Yeah.
I think what that mounted to is you're trying to build the engine, you're also trying to film what you're doing, and there's just too many things going on all at once there, and I'm not convinced that's what we're gonna find.
So our camshaft, they sent us the wrong frickin' cam card. We know the duration at 50 thousandths is supposed to be 218 degrees. We think the advertised duration, so at 6 thousandths lift, is supposed to be 268.
Okay.
Like a comp 268. And if I installed this right, the way we had them grind it, we have a 108 degree lobe separation angle. So we should, doing the math from this being installed at, I think we came out at like a 108.75 center line on the intake.
Okay.
I mean, really close to 108, which is where we were going to install it. So if we take our 108, well, if we take our 268 divided by 2 minus 108, we should be open 6 thousandths. We should have 6 thousandths cam lift at 26 degrees before top dead center.
Okay.
I think. I hope that I'm saying this all right. So let's just slowly. Okay. 1, 2, 3, 4, 5, 6.
Yeah. And again, we're having to do this off of the harmonic balancer now rather than a degree wheel.
I think it's pretty freaking... I'm gonna take a picture of it if I can. So there's 20.
Okay.
Here's 30.
You're halfway.
I'm gonna say we might be a couple degrees off.
But it's not like we're 1 tooth off. Because if we were 1 tooth off, what was it we figured out we'd be?
If we were a tooth off, we'd be like 17 degrees off. 10, 20, 30, 40, 50.
Yeah.
And again, I'll take a picture here.
We're at top dead center.
We're at or just past top dead center.
Okay.
I don't know if the camera will pick that up, but if not, when I edit this, I can try to throw that in. And from when I agreed to degree, I think that's right about where it should be, is 0 when I degreed it.
So at 50 thousandths, you should be at 0.
Yeah.
Okay, well, I can't tell you how many motors I have taken back apart the next day after I slept on it and couldn't remember if I lined the marks up, and they always are.
Yeah. No, it was just starting to make me question it, and I went and I was like, I didn't record that part. And then I was like, no, I definitely recorded it. So I went and looked at the video, and of course I had the camera at an angle, so note to self,
take a picture of that.
Take a picture when I put the timing cover on, just for peace of mind.
Yeah, just so you can go back and see for sure. So I'm going to say we're confident you have the timing chain on right. Okay, well, I'm back to...
It's got to be...
It's got to be
an ignition thing.
Yeah, it's got to be that we keep getting these junk distributors and we can't come up with a good distributor here. Let's go ahead and put that Reman point one in.
Okay. I put it, for the camera, I put an air fuel gauge in the driver's side tailpipe.
Do you want to also show the people what your wear pattern's looking like on the end of the valve and see if we can get some comments on that?
It's slightly offset to the outside, but it's not insanely wide.
No.
In my opinion, the width of the pattern being too wide, I would rather it be off-center and skinny than on-center, but wiping all the way across the valve.
Yeah, because wiping all the way across the valve is going to give a lot more side action on the end of that valve stem and wear out the valve guides.
Yeah, and I've talked about that really in depth on a previous video. I think in the 383 build, I talked about my opinions on that. They're not the same as everybody else's opinions all the time, but...
You know what they say about opinions.
We're gonna run it with this distributor again, because we did have it running with this distributor. And do you agree with what I'm saying, where it seems like you can either move the timing and you can have it run at high RPM, or you can move the timing and you can have it run at low RPM, but you can't have both.
It was very much whatever that distributor has in it for a curve or whatever. Yeah, we'd advance it up and you could get 2,500 RPM and it ran real nice, but you'd bring it down to idle, it'd start missing. And then you'd adjust the timing so idle was nice.
And then you can't bring it up.
But then you can't bring it up.
Okay, so at this point, we've gone back to an old school points distributor.
We're as basic can be.
And it's gonna fire up and run just fine.
It's gonna fire up and run perfect. We'll see. Be a joke if it does. Okay, hang on. What haven't we got right? We haven't got the ignition plugged in.
It wasn't plugged in. So now it's gonna fire up and it's gonna run just right. Ready?
Yeah. Look at that. Where are we at?
That's 17 right there. Oh, you're like 15, but it's kind of jumping because it's not running
like
good.
it.
$34. Okay. We have water? I guess I forgot to look at that stuff.
Yeah.
Is that the idler being noisy?
Better than it's ever been yet.
That's the idler.
Oh yeah.
Noise, right?
Yeah.
Yeah, I mean, again, we haven't calibrated it. It said 184 horse at 4,000. I mean, my thing is like, it's running the best it has run with that distributor. So it sounds good.
It screams.
Use a 3%.
Oh.
Yikes. Yes.
We're about out of fuel.
Gas. Do you want to just to prove it to yourself, do you want to put that one back in?
I want to put that one back in just to prove it to me.
And if it doesn't work, if you want that one in there,
I'm not. No offense, I'm not going to run it.
No, I didn't expect you to run that one, but we had to go to something
to prove it.
as basic can be to prove that these other things are not working. I guess my little roller stayed on.
that thing makes a lot of noise.
Oh,
Yeah.
it's like terrifying.
Yeah.
I'm waiting to hear it.
Yeah.
Well, see, that's a wore-out roller from my crankshaft polisher.
Shut it off.
I was going to say shut it off, and let's put that the distributor we started out with at Pertronics, just to prove to ourselves that it's not the distributor, because we never could get it to run.
But it runs, I think it runs good right now. I don't understand why it has to have so much timing.
Yeah,
But-
I don't understand that either. Mark's there, you just ran out of gas.
So we've gone back to the original Pertronics distributor. Now that we know it runs,
I want to prove to myself that it was not us condemning this distributor.
yeah.
Let's see if we can make it run, or if there really is a problem.
Okay, we have the vent out of the gas can.
Yeah. Okay, I guess I'm ready to see if he'll start. You might have to crank it a little to get, or else see, a fuel pump should pull it up right away. I forget.
Okay. Ready?
Yeah, go for it. Go for it. So that one does run. But where we think it fires is so far off, because I can't even turn it far enough now to get in time. So shut it back off.
Okay.
So let me move it one tooth.
Okay.
And let's see what happens. What? Yeah. Keep going.
Keep going.
There's something funny about that one.
Ready?
I guess.
Okay.
Is where the points were running well.
That's 31.
What's that?
It's kind of bouncing, but 20 some. I just don't understand why it would have 30 degrees.
I don't know. I'm puzzled as puzzled can be.
What'd you say?
Running so happy with that part.
That idler's making so much noise.
Yeah.
At least that's what we tell the customer. Made like exactly the same power and torque as it did with the points. Well, I feel like we know that that other distributor is messed up.
Yeah, something is foobar in it.
Sounds good.
Yeah.
Sounds really good.
Yeah.
You're like lowest you got was 9.8.
I may not have had this like quite high enough because I only got one more data point.
Yeah.
But it's still going up. We had 203 horsepower and the torque has stayed steady.
That little 289 gained 10 horsepower taking the mufflers off. And these mufflers are definitely choking that motor.
That like start getting happy.
It gets unhappy. I think it gets a little happier every time you do that.
So torque starts to drop off pretty aggressively after 4,000, but from 2,000 to 4,000, it's like pretty flat. I mean, at 2,000 it's 270. At 3,750 it's 266, and it's just kind of right in there that whole range. but by 5,000 you're 216, so it's dropping off pretty aggressive. And then
But I mean,
205 horse.
And I guess it's going to be kind of a feel it out, like how does it feel in the truck?
Yeah.
Because it might be a lot of motor for a truck doesn't weigh a whole lot.
What does that truck weigh?
I want to say, without the interior, got it completely done, it was like 27 something.
Yeah. That's what my little Chevy Vega used to weigh with V8 in it.
Yeah. And with 411s and a Dana 60 out of the rear, it's 300 horsepower would be a lot.
We spent at least a day chasing a screwed up flamethrower distributor,
Yeah.
which may have been your problem
A long time ago.
when it may have been the reason that the engine is here in the first place, potentially.
You had us up there to your house one time. Was that you couldn't get it to run then or something?
Yeah, I brought you guys up to help me break it in. And then I ended up getting broke in, and then the stutter at idle and sometimes driving, it just kept getting worse. I brought you up to see what you thought. Because I was concerned it flattened the cam load.
Yeah, and it wasn't that at all.
But at this point, we had the points distributor in. It ran good.
Yeah, it up to that point between the Pertronics and that Chinese HEI or
$30 on Marketplace. I don't know why it didn't work.
I don't know why that didn't run perfect, but it at least would run with it.
Yeah.
But then the old Reman Napa,
O'Reilly's points.
is that where we got that?
Yeah.
That was O'Reilly's points distributor that I still think is worn out. It's about the worst Reman, or not what I would consider a Reman should be. But it ran pretty good with that.
Yeah. And we did what, one run with that?
Yeah, I think
We did
so.
like one run with that, and then we put
Prove it to ourselves.
and then we tried to put the old Pertronics in again. Didn't work.
Didn't work.
So then we bit the bullet and put this one in. I guess we didn't bite the bullet. You bit the bullet and put this one in, and I mean, right away it
Yeah, it ran.
ran. I don't understand why we're getting like 27 degrees timing on our timing
I don't
light.
understand why we're having to run so much timing other than we need to go back and verify and make sure the mark is correct. But
Maybe I completely botched the mark on that.
You'd had to really botch where that mark is to be that far off. But
It's kind of to the point where
that match, this thing, we questioned it to the point we wondered if your timing chain was on right. So
Yeah.
we checked it against the overlap on the valves.
and the valve timing seemed right.
Yeah.
So yeah, that's needs some more investigation. But then we did a run with this, and the numbers were almost identical to with the points distributor, I'm pretty sure.
Yeah.
And then we did a couple more runs here. Looks like it's maybe on the rich side
Yeah.
during the runs.
Looking at your numbers there on that air fuel
Gauge.
Is that what that is? I think we can lean the carburetor down just a little bit.
So we don't have any more parts to do that right now.
Yeah, we'll have
But
to get an assortment of jets. to
it
do
makes
that.
a crazy amount of noise because of our idler to tension the belt. So we gotta, in the future, we need to put more thought into.
Well, we probably just need
that.
to invest into
Electric.
one of the little electric motors to drive the water pumps with instead of trying to do it this way.
But I think from this point, we can mess with it a little bit more on the dyno here. Again, our dyno has not been calibrated. and I know there will be a million comments saying to calibrate it, but
But again, we're not after big numbers. We're after consistent numbers to prove things work.
yeah. Uncorrected data, because it's still climbing. So if you wound it up past 5,000 RPM, it might make more. But at 5,000, we had 205 horsepower, and we were talking from 2,000 RPM to about 3,750. You're right in the 270s for torque. So it has a really flat torque curve down low. And I don't know. I guess.
I mean, this is one of them things, no matter what you have, you're never happy. You always wish it would do more.
Yeah.
But
we were trying not to blow a bunch of money on something that
yeah,
hopefully we could just get it put back together. And
we're hoping it was going to be a very low budget, kind of freshen up on the engine, just a little bit more camshaft. And then Caleb decided he wanted big carburetor and manifolds, so he spent as much money right there as we did in all the rest of it for parts.
Yeah.
Yeah.
But that's just the way it goes. So anyway, I think it came out pretty good. So like and subscribe.
Go buy
drop
one
a
of my
comment.
t-shirts.
Drop a comment and tell us why the
Yeah.
timing is the way it is.
Somebody tell us why this thing has to have so much ignition timing. There's a missing puzzle piece that we have not figured out.
Okay, on to the next one.
See ya.